Okay, here we go. This is video 2 on partitioning a segment, and I hinted at the end of my last video that there was one case that we hadn't considered, and that would be what if our point that we're partitioning a segment into is, when we're partitioning into two parts, what if our point is not a nice coordinate point? So I'll give you a hint, that's what's going to happen here. But let's take a look at this question. So we're trying to divide. I've got the segment drawn for you. If you don't have graph paper, that's totally okay, because like I said, this one we're going to end up taking off the coordinate graph anyway, and we're going to turn it into a problem straight from basically worksheet D that you guys have done, where we're going to use similar triangles. So no big deal, you can just sketch it in as good as I can. My graph isn't even exact here. So we're trying to partition AC into two parts such that AP to PC is a ratio of 2 to 3. So we could interpret that as AP is going to be 2/3 of AC, or sorry, AP is going to be 2/3 of PC. PC is going to be 3/2 or 1.5 times AP. Or we could say, if we're going to talk about the whole length, notice that we've got 5 parts total here. If we're talking about a ratio of 2 to 3, that's total of 5 parts. So AP would be 2/5 of the whole if we're talking about AP to AC using the whole length. So just some interpretation there, but if we take a look at this and try to make a guess, well, I know that P is going to be less than halfway from A to C, because AP, like I said, is going to be 2/3 of PC, slightly smaller. So, I don't know, I would guess somewhere around here, if I'm just taking a guess. Let's try to get that in the line. And it almost looks like it could be at that point there, but if I go ahead and map my triangles out, well, I'm going to have over, it almost seems like it could go over 3, and then up, I wish I had another color here. Let's go ahead and do black for my color. Well, I guess I'll do red. Up there, and then if I went over, let's see, it'd have to be 1.5 times as long as 3, which would be 4. Yeah, it's not going to work. So it's going to be somewhere sort of where I drew it. But the question is where? What's the decimals that are giving me that? So what I'm going to do at this point, since I'm recognizing it's not a whole numbers, I'm going to totally take it off the coordinate graph. And I'm going to redraw that picture, but bigger on the right so I can sketch in everything that I know. So we can go ahead and put those points there, but what I'm really worried about is having those 2 triangles. Okay, so I guess I should put some letters in there just so we know what's going on letter-wise. So this is A, this is P, and then this is C up there. And then even more important than those letters are, okay, what lengths do I know here? Because there are some lengths that I know, but there are also some lengths that I don't know, and we need to separate between those. So did I just move that off the coordinate graph? Okay, let's keep that there so that goes with, but let's... my graph isn't liking me right now. Okay, let's keep things where they started. Okay. So what I'm going to do is I'm going to start with labeling that I've got a ratio of 2 to 3. And again, remember, that's like 2 times something and 3 times something, but we're just going to use those to represent it because it's going to reduce to that. And we're going to end up making a proportion, and it doesn't matter what my original lengths were. If they reduce to 2 to 3, I'm good to use 2 and 3. So then I don't know where exactly point P was. That was totally a guess, which means if I don't know exactly if this is right, then I don't really know this length, and I don't really know this length. Those were guesses. Okay, so I'm going to make up letters for those, and instead of using A and C, since those are already in the problem, I'm going to use the variables B and D. That's just my choice. You can use whatever letters you want, but I'm going to call that B, and I'm going to call that length D. So B is my yellow length, and D is my red length. Now, I can't solve for more than 2 variables at the same time, and that's only if I have 2 different equations. So when I name my next lengths, I'm going to have to be real careful here. This length here, I do know I don't know what that length is, because again, I don't know exactly where P is. But I know this whole length. I can count all the way over to C, and that would be a length of 8. So if I called this length B right here, then just think with me for a second. If this whole length is 8, and this is B, then this has to be what in terms of B? You got it. That's going to be 8 minus B. So I'm going to call this length right here 8 minus B, and that's my yellow length. And then using similar reasoning, I'm going to call my length up here, this length, I'm going to call that, well, let's see, this whole length right here is 3 units up from A to C, and this length we call D, so this would be, if that's 3, this part here is D, the rest of it is, you got it, 3 minus D. So 3 minus D is what that is. And that was the hard part of this problem, because at this point, it's going to turn into similar triangles, and you guys are good at similar triangles. I've got right angles there. I've got these corresponding angles that are going to be congruent, because I've got horizontal lines on my coordinate graph are parallel. So I've got similar triangles, and if I can recognize similar triangles, the ratios of corresponding sides have to be the same in all similar triangles. So let's make some proportions, and we're good to go. So I'm going to have, let's start with my yellow lengths, and my yellow lengths make a ratio of B over 8 minus B is going to have to be equal to 2 over 3. So what did I just do? I just made a ratio of my horizontals to a ratio of my, if you want to call them the hypotenuses, is one way to look at that. And now I have something that I can solve. So let's go ahead and solve that. So 2 times the quantity 8 minus B equals 3B. Gives me 16 minus 2B equals 3B. 16 equals 5B. No wonder we were having troubles with this, because like I said, not going to come out nice. Oh, I wish this would move together. Let's do it this way. So, you know what, while we're moving, let's go ahead and move things over just a tad. So I'm going to get B equals 16 divided by 5, which is, what, 3.2? 3.2. So no wonder, yeah, it wasn't working out, because we got this nice decimal. Okay, so let's go ahead and look for D, and then we're going to come back to interpret our answer and figure out what we just did. So now I'm going to make a ratio of my length of D, which is my small triangle here at the bottom, and then 3 minus D, and then put that with the hypotenuses, or I could put that with these legs. If you like to make that extended proportion, you could have just done an equal sign right here. I'm setting it up as 2 different proportions, because most of you like to do it that way. So I'd have D over 3 minus D equals 2 over 3. And again, just so you can see where that's coming from, those are my red lengths, that length and that length. And then I've got that same ratio of my hypotenuses, which is the lengths I'm looking for. And I'm going to let you go ahead and solve that. So pause the video if you need to, and see if you can agree with my answer of D equals 6/5 or 1.2 for the length there. Okay, good. I'm glad you agree with me. Now we're going to go ahead and try to interpret what we just did, because we didn't actually find the answer. The answer is find the coordinates of point P. And we just found some lengths here. So here's where I need to take it back to my coordinate graph and figure out what I just did. So bear with me while I move things around here and try to get things situated. And I might have just messed this up. Okay, let's see if I can. Okay, I think we're pretty good there, and the only thing I lost is my D value of 1.2. So we'll put that over there. So we've got that. Okay, so my question is, and let's go ahead and, oh, come on. Nope, not what I wanted to do. Okay, it's not going to shrink for me. My question was, what's my actual answer? How am I going to figure out point P? So we'll work with this. I'll just write over the graph, and you guys can follow, I think, pretty well. So I'm trying to find the coordinates of P. And what I need to do is figure out, okay, B and D are distances that I traveled from A to get to P. B is how far I went over from A in the x direction, if I think of it that way. Go back to your coordinate graph here. So B is just this length. That means that length is 3.2. Well, that makes sense. I'm over a little bit more than 3. It's pretty much what I said. And then I'm up a little bit more than 1. But that's from the coordinates of A. So I'm basically going to go back to the coordinates of A, and I'm going to add to it. So P is actually going to be my x-coordinate of A, oh, jeez. Okay, go away. P is going to be the x-coordinate of A, which is 2, plus my B value, 3.2, comma, and then my y-coordinate of A, which is 5. I'm getting that straight from here, guys. And then plus 1.2. Note that if my triangle was the other way, if I was slanting down, if my AC was like this, then I might have to be subtracting from A to get down and over. Subtracting and or adding. So you just got to look at what direction. We could also be going this direction. So I'm totally going off the graph here, and I'm visualizing what's happening. And when I do the math here, that gives me 5.2, and that gives me 6.2 for my y-coordinate. So this is my final answer here for the coordinates of P, right there. And hopefully that makes sense to you. I would draw it here smaller on the graph, but the best thing I can say is visualize this entire thing is on here. And I just went over from A. Okay? If you want kind of, I don't know if I have like a formula to give you, but I would say that we really took A, the x value of A, maybe we could write it this way. Let's write x sub A plus B, and then x sub, nope, not x, y sub A plus D is really how I got what I have here. Okay? Now, I know this video is getting a little long, but stick with me. I'm not going to do many examples. I'd rather take this one, and I want to show you one other way of doing it. So I'm actually going to redo the whole problem. And this time, I'm just going to make my triangles look different. And it might make more sense to some of you. Some of you might really like what I just did, and some of you might prefer it the other way. So it's worth taking a minute, I think, to go through this problem and do it a completely. So here we go. We're looking at the same picture. And this time, I'm still going to take a guess. So I'm still going to guess that P is right here. And instead of drawing my triangles as I did last time, this time I'm just going to draw over all the way from A to C, and up all the way from A to C, or where I was. And then I'm just going to draw straight down here. Okay, and I'm going to do the same thing. I'm going to take that off the coordinate graph. So let's take that off the coordinate graph. There's AC. There's my horizontal and my vertical. And here's my guess for P. And this problem should, again, look very similar to a problem that you've seen in this chapter. It's off the coordinate graph. Now it looks like something that we can handle. So let's just recognize that we do have similar triangles here. We've got right angles. And therefore the lines are parallel. We've got a shared angle here. We also could say that we have parallel lines, and therefore my triangle proportionality theorem would apply with my parallel lines there. So we've got all kinds of good things going on here. Let's see what we can do with this problem. So I've got a ratio of 2 to 3 here. And now I need to think about what do I know. So things that I know in this problem. Well, I know for sure this length here, because I can count that. I can count horizontal on my graph, and that's 8. That's that entire length there. So I'm going to use brackets to represent that. And then I know that this entire length here has to be 3, because I'm counting that on my coordinate graph. What I don't know is I don't know for my smaller triangle here, I don't know this vertical length, and I don't know the horizontal length, because that's my guess of how far did I go over and how far did I go up. So I'm going to have to pick letters and make those letters. So let's go with what we did last time. Let's call this B, and let's call that D. So the question is, how can I make triangles, or how can I make proportions to help me here? And I really have a lot of options, and that's what I like about this one, is I could do small triangle to big triangle. I could also do ratios of parts. I don't know this length right here, but I could easily call this 8 minus B, and then do 2 over B equals 3 over 8 minus B. So it's up to you. If you're doing small triangle to big triangle, we could do something like B and 8, and then I can make a ratio over here, 2, instead of using 3, I'd be doing 2 to the whole length is 5. So notice that I just inserted a 5 here to help me out. I don't think you're going to disagree with me that that's 5, but maybe you didn't see that or weren't thinking to use that. So I'm going to go ahead and start. I like to start with my variables, and if I can make a ratio of B to 8, all I have to do is match it on the other side, and I'm saying 2 over 5 would match that. And then let's see what I can do with D. So, I don't know, I'm seeing D over 3. Anybody else seeing that? So I've got this ratio here, so I just need to match that. Well, that's small triangle to big triangle, so I got to go small triangle to big triangle. That's going to be 2 to 5 also. So now I'm just going to cross multiply and divide. So I've got 5b equals, yeah, you can do it quicker than me. I'm just going to do it in my head and then tell you what I'm writing down. 5b equals 16. So there's my b equals 16/5. And then I've got 5d equals 6, which is giving me d equals 6/5. And from there, to get p, I would be doing the exact same thing that I just did before. So if you need to look back at what we just did, we're going to have to move from point A. So we'd be looking at where am I starting, and then I went over B and up D. So it's really just a difference in the setup of the triangles, okay? Your choice. There's not a right or wrong. Before I move on, I am going to say one more thing. These aren't the only two ways to do this problem. I think they're the most generalizable to any problem, but I always have students that like to sort of think of it in this way. I'm going to verbalize it. They say something like, if point P is 2/5 the distance from A to C, then the x-coordinate for P would have to be 2, because this is 2, plus 2/5 times 8, because 8 is my total distance from A to C, so if I go 2/5 of the way, that is 16/5, and therefore they get 5.2. And the y-coordinate they do as, and I'm not going to write it all down, but the x, they said, they would say something like this, 2 plus 2/5 times 8. And let's do that 8, because that's where it's really coming from, that length there. And then the y-coordinate, they say 5, starting at 5, plus 2/5 times the rise. Well, the rise from A to C was 3. And that gives them their answers directly. This gives you your 5.2, and this gives you your 6.2. So just a third way to think about it to try to totally confuse you. Okay, I know this video is getting long, so I'm going to stop this video. I'm going to make one more video example to help you out with this, just so you see another additional example.